All right, 15.3, triangle inequalities. So dealing with triangles still, but now looking at how side lengths and angles all relate to each other. Our essential question: how can you use inequalities to describe the relationships among side lengths and angle measures in a triangle? So the triangle inequality theorem states that the sum of any two side lengths of a triangle is greater than the third side length. So here you get AB plus BC has to be greater than AC. BC plus AC is greater than AB, and so on. So to be able to form a triangle, three inequalities must be true. So to prove that the given side lengths can't form a triangle, you'll need to show that one of the inequalities is false. So example 1, determine whether a triangle can be made with the given side lengths. So as we check, I'm going to start with 4 plus 8. Is that greater than 10? That one checks out. Then 4 plus 10. Is that greater than 8? That one checks out. And then 8 plus 10, is that greater than 4? That one checks out. So this triangle would be true. You can form that triangle. Now for B, we go 7 plus 9. Is that greater than 18? Well, 7 plus 9 is 16. And that is not greater than 18. So this one would be false. Can't make a triangle out of that one. Now, the somewhat shortcut is you only need to check if the sum of the two smallest numbers is greater than the biggest number. Okay, now why is a question I want to discuss when we come into class the next day. All right, so I want you to try C and D and see if you can figure out which ones would make a triangle and which ones would not. All right, find the possible side lengths in a triangle. For any two given side lengths, there's an infinite number of possible third sides. However, the triangle inequality theorem restricts the third side length to a specific range of values. So find the range of values for x using the triangle inequality theorem. So we know that 10 plus 12 has to be greater than x. So then that gives us that 22 is greater than x, which means x is really less than 22. And then for the low side, we know that x plus 10 has to be greater than 12. So when we subtract that 10 over, we get x is greater than 2. So then what that tells us is that our range for A is 2 is less than or equal to x, which is less than or equal to 22. And that would be our range of the possible values for x, from our smallest to our biggest. So as we look at B, we can see from A that really what we need to do is add the two values together to get our high end. So that's 30. And then subtract the two known sides to get our low end. So then that tells us that 0 is less than x and less than 30, because we're going to go from the lowest possible value to the highest possible value. Now, why does 0 make sense in this equation? It's a question I want us to answer when we come into class. So the range of the missing third side is the two sides subtracted and the two sides added. So I want you to try C and D on your own. We'll discuss those when we come back into class. All right, ordinate triangle, angle, measure, and side length. The largest angle is across from the largest side. And that should make sense. The larger the angle, the more this opens up, the longer the distance that we have to cover there. So here, for this example, our large side is 7.2. So then the angle across from it is angle A. And then our medium is 6.5. And the angle across from that is angle B. And then our smallest side is 4.3, and the angle across from that is angle C. Okay, so again, the largest side is across from the largest angle. So the converse of what we just did is still true. So here, my largest angle is 121. So then my largest side is going to be RQ. And then my medium angle is 37. Then my opposite side is PQ. Then my smallest angle is 22. And the opposite side from that is PR or RP. Don't really care what order you write those in, so we could have wrote RQ or QR, PQ or QP, RP or PR. All right, so example 3 and 4, I want you to go ahead and work on those, and we'll share out on those in class. All right, elaborate. When two sides of a triangle are congruent, what can you conclude about the angles opposite those sides? So go ahead and write down your answer, and again, we'll discuss this when we come back into class. And last, essential question check-in. Suppose you're given 3 values that could represent the side lengths of a triangle. How can you use one equality to determine if the triangle exists? Okay, time for Fun Fact Friday. First person in each class that comes to me with the correct answer to this question might get a little bonus. Name the 2 movies that were filmed at Notre Dame.